Hello. So I think today is finally the day that I will make this video happen. Measures of central tendency means. Why do I say means in the plural? Because there are many means, and I will only talk about one today, and it is the arithmetic mean. Sometimes this is the mean that people know, and in here, all elements should contribute the same manner, as in, I want to replace n elements of the sequence that we want to have the mean by one element n times, as in, I want this property here. I want that the mean n times replaces the sum of all elements. And from this, we can work backwards actually to get a definition for the arithmetic mean. As in, I want the mean that can be represented in both of those ways to be the sum of all elements in whatever we are doing the mean on. So this can be heights, this can be populations, this can be um, speeds, this can be positions. There are many examples, and this is an expression of the sum of all elements from 1 to n. So we got this summation sign here from 1 to n of xi divided by n. N is the number of elements. You could, if you want to be fancy, instead of putting n, you could put the sum from 1 to n of 1, because it would be counting each element, but that's a little bit too pedantic. And this, I mean, in the arithmetic sense, is good when data is equally symmetrically, between quotation marks, distributed. That is, this is good if it's not, it doesn't have outliers. So this is when arithmetic means are good. They're not very good if there are many outliers, because the arithmetic mean is very sensitive to outliers, just like other means are too. And unlike, for instance, the median. And this is bad when there's a lot of skewed data and a lot of outliers. And in that case, you should use the median instead. And you can do definitions in the continuous too. The difference between here and here is that instead of a sum, we have an integral. Instead of a 1 multiplying here, we have a dx, because we are in the continuous instead of in the discrete realm. And instead of n, we got an interval for the function. So for instance, in the continuous, for the mean value in y of a function, we get this expression. So I gave an example in the continuous, and I'll give an example in the discrete realm. So in the continuous, I'll give this example. This is a parabola. This parabola has the concavity down, and it's going to be x times 1 minus x. This is being fancy. It's x minus x squared. Integrate between 0 and 1. This gives us, we integrate a polynomial, it's x squared divided by 2 minus x cubed divided by 3 from 0 to 1. This is in 0 is 0, this is in 1 is half minus 1/3, which is 1/6. So that is the average f, and visually this is substituting the parabola by a straight line that's uniform. So you are doing here is substitution of the function by what it would average in the whole interval. So in this case would be straight horizontal line of 1/6 height. And this would be in the continuous, and I will give you an example in the discrete in a moment. What I'm gonna do is I'm gonna get a die. I'm gonna take like 5 values and I'm gonna take the average of it. Just a moment. Okay, normal run-of-the-mill hexahedral die. So this is gonna be 3, 6, 2, 4. Let's take only 5 values. 1. So we're gonna take the average of those 5 values and we're gonna do it in the arithmetic mean sense. So we take all these values that we sorted here. They are gonna be x1, x2, x3, x4, x5, and so there are 5 values in total. So we're gonna sum all of them. This is gonna give us 9 plus 2, 11 plus 5, it's 16. So we get 16 divided by 5 is gonna be our our average x in the arithmetic mean sense. And this is very close to what is expected for a fair die that is a hexahedron, which is 3.5, which is the sum of the lowest with the highest divided by 2. Under the assumption that the die is fair. There are other types of dice. This is a D20. This particularly has 10.5 for average. And one of the problems with dice is knowing if they're fair or not. One of the tests people do is floating them in liquid and see if they have a preference, a bias toward one side. If your die has it, it's probably not fair. Otherwise, you can throw it many times. But besides that, that's the analysis of the random number generator is not the objective of this video. So that's it. Bye for now. And please give a like and subscribe. Bye.